All right, welcome again to what I hope are good choices. Check mic check 1 2 1 2. Really critical I do that. So this is going to be continuing with the Automate Your Network uh, book by John Capobianco. I believe that's how it's pronounced. I hope I'm getting it right because he's a really important figure in Cisco DevNet. It used to be Hank Preston was like the main figurehead, but it looks like John Capobianco is leading the charge when it comes to AI, which is going to be a really important new skill set to catch on to as technology progresses. And I'm trying to make good choices in that regard, so I'm using AI every day as my personal tutor. There's a lot more ways to use AI besides just that. You can use it to help you write code. There's tools like GitHub Copilot. There's tools like GPT Engineer. So that's another way to use AI. I am using AI for things like job searching, things like resume creation. I find they're not quite there yet with that. Like as I mentioned in my last video for this series, AI still has quite a bit of limitations, which can be hard. For example, if you play chess with the AI, it can't like argue with you about like whether or not you made a move that's legal. It can't set up the chessboard itself and like keep track of all the pieces on it, and it can't even over the course of an entire chess game like remember the moves that it made and play a whole game all the way through. And try it yourself, because you'll find things are going great, but then oops, something went wrong. I made a mistake, they made a mistake, and it's like it's not quite with humans, because like with humans you can play chess, you can get something wrong, you can get in an argument, you can look it up online, look it up somewhere, and you can keep playing the game all the way through, and you can be satisfied with who won and who lost. You can do that with a human, but I feel like with a AI, we're really not there yet. If you want to play chess against an AI, you have to play against an AI designed to play chess. And with humans, you can play chess against somebody who's never played chess before, and that can be a fun experience. All right, so let's keep reading. We're gonna start chapter 4, which is where to start with network automation. So start by doing what's necessary, then do what's possible, and suddenly you're doing the impossible. This is a quote by Francis of I've never heard of this person. Let's do a quick look up. Sometimes I'm just interested to fill in the gaps of my knowledge. I don't want to spend too much time getting lost in a tangent, but I'm just interested in who this is. So this is so this is a Italian mystic and Catholic friar who looks like he founded this. And what this is a group of related um, 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 so it looks like this is somebody who kind of like revolutionized the Catholic Church, and like had the uh yeah, I wish I could see more of a. Oh, well, let's ask the AI. I love this so much. Okay, who is Francis of Assisi, and why is he a notable and important figure, and what would you say is his most important quote?
Francis of Assisi is a medieval Christian saint and the founder of the Order of Friars Minor, commonly known as the Franciscans. He was born in Assisi, Italy, around 1181 or 1182 and died in 1226. Coming from a wealthy family, Francis led a carefree life until a series of events, including a military expedition and a serious illness, led him to reconsider his priorities. Turning away from worldly riches and comforts, he embraced a life of poverty and spirituality. Francis is notable for several reasons. Emphasis on poverty and simplicity. Unlike other religious orders that existed at the time, Francis's Franciscans took vows of extreme poverty, aiming to emulate the life of Christ as closely as possible. Love for nature. Francis is often depicted in the company of animals, emphasizing his love for nature and his belief that all of God's creation should be respected and loved. Role in church reforms. At a time when the Catholic Church was criticized for its opulence and lack of focus on spiritual values, the Franciscan order became a model for renewing the church's focus on humility, piety, and devotion. Stigmata. It is said that Francis received the stigmata, wounds resembling those of Christ's crucifixion, making him one of the first recorded individuals to display such phenomenon. Ecumenism. Francis is known for his attempts to bring peace during the Crusades, even traveling to Egypt in an effort to negotiate with the Sultan and find common ground. His most famous quote is likely the prayer of Saint Francis, often attributed to him, which starts with, "Lord, make me an instrument of your peace, where there is hatred, let me sow love." It's worth mentioning that while the Franciscan way of life has some elements that could be seen as valuable in a remote work setting, such as simplicity and focus, it's far from being a guide to career success in modern, digital age.
All right, I wasn't. Oh, here we go. So, Lord, make me an instrument of your peace. Where there is hatred, let me sow love. Let's see what was used in the book. Start by doing what's necessary, then do what's possible, and suddenly you're doing the impossible. So, yeah, kind of interesting to fill in the gaps here. Most importantly, like, this shows like the difference between, what a wild, crazy world we're in now. I did a Google search for Francis of Assisi. And, I got the Wikipedia page. From there, I was able to go down tunnels. But I was really having trouble making sense of who this person actually was. From ChatGPT, we get a list of why this person might be notable. So, this is the shift of... okay, so this is somebody who, so this is somebody who, like, had a love for nature, who had a role in church reforms, and, attempted to bring peace during the Crusades. There you go. Like, that's the general overview, 1,000-foot bird's eye view of, like, no details, all course. Like, that's what I was looking for when I was doing the Google search. I just wanted some general sense of, like, who this person was and why they were important. And, the AI makes up things, but I think this is probably generally true. He's important because he made church reforms, and he, during the Crusades, tried to end the Crusades. So, yeah, that's makes sense. All right, so moving on. There may be immediate needs for an automated solution, and while it may be tempting to jump right into making automated changes to the network, it is strongly recommended to begin with information gathering. So the other thing too with that is you want to get your, I forget what it was called, but it's the workflow. It was, yeah, this is describing it. I should put this in my notes. You want to get your network development lifestyle, or sorry, I just keep saying lifestyle, which I mean, that's kind of what it is, but your network development life cycle, this is what you want to get. So it's not necessarily right away about, even, just doing things with automation and with code that can save time. It's about creating this just cultural shift. So, like, yeah, it's important to get, impress people with what you're doing with the code, but at the same time, you want to be redefining how things are done. So the most important thing, regardless of what you're doing, is that you're building that new network development lifecycle. All right, I don't know where my notes file went, which is why I have version control. Let's see where it went. Okay, so let's look at my commits. So here we go. I added the lab file. So let's take a look at what I did. So yep, I just added a bunch of files. Didn't delete anything. Let's see if the notes file is in there. So nope, the notes file is not in there. So looks like I didn't modify the notes file at all. Oh, the other thing is, so this is what, and this is important to note. The reason we're not seeing the notes folder here, is because I'm in. Well, I'll show you. So if we go here, which is the repo, and then we go just to the main folder, we do a git status. We can see, and then we do a git branch. I'm on the main branch, so the reason I'm not seeing the notes folder is because the notes folder is on this second branch. So we need to switch over to that branch. So let's do git pull just to make sure we're all up to date. And then let's do a git checkout. And then I forget what I named the branch. I think I named it Graham's book read through. Yep. Okay, so now this is where it gets tricky. So here, and let's ask the AI. It's like, what an amazing world we live in. Like, seriously, I'm dumbfounded every time. Okay, it's like, what would I have done before this? I mean, I honestly would not be, I would just not be getting as much out of books. You know, I'd just be mindlessly doing things. I'd be lucky to, pass a certification exam, and, I just walk away from it with some small percentage of what I needed to learned. And with the AI, I can just learn everything I need to learn and more. So here we go. I'm going to say now in my actual GitHub repo online, I do have a branch named Graham's book read through. Why isn't this branch shown? How can I switch to this branch? Do I need to download it from the repo? Why wasn't it already included?
You're facing a Git issue where your local repository is not aware of the remote branches. This is an important skill to have down cold, especially since mastering a niche like network automation will likely involve a lot of version control for your code and configurations. Here's a step-by-step guide to resolving this issue, which also ties in with your goal to become proficient in areas that are valuable for remote work. Fetch all remote branches. Run the following command to fetch all the remote branches to your local machine. This won't merge or modify your working files, but it will update your local Git with the state of the remote. Bash copy code git fetch origin check available branches. Now, when you run git branch A, you should see a list of all the branches available, both local and remote. Bash copy code git branch to switch to the branch. Once the remote branch is fetched, you can switch to it using the following command. Bash copy code git checkout grams _book _read through. Alternatively, you could also use bash copy code git checkout b grams _book _read through origin grams _book _read through. This command will create and switch to a new local branch that tracks the remote grams _book _read through branch. Setup tracking optional. If you use git checkout grams _book _read through and it does not automatically set up tracking to the remote branch, you can do so manually. You're facing a Git issue where your local repository is not aware of the remote branches. This is an important skill to have down cold, especially since mastering a niche like network automation will likely involve a lot of version control for your code and configurations. Here's a step-by-step guide to resolving this issue, which also ties in with your goal to become proficient in areas.
Oh, it looks like it repeated it somehow. I'm not sure if I hit a button by accident, but it looks like the first thing we need to do is fetch all the remote branches. So I did that. You can see all the remote branches are listed here, but we have them listed as remotes. So we did that. That's the next step to get that output that we're seeing there. Now, with this step, we should see a list of all the branches available, both local and remote. So, yep, the list I think makes a lot of sense because, this was the issue we were having. We didn't have any of these. So we have our local ones here, the main branch, but we don't have any of these other branches as local ones. They only exist as remote ones. Okay, so the next thing is once the remote branch that we want is fetched, we can switch to it. So let's do that. Oops. There we go. I overwrote my clipboard contents. Okay. I did not mention any files known to get. And we used get checkout for that. So, okay. Well, let's try this alternative command. Maybe this will work instead. Nope. Okay. So once the remote branch is fetched, you can switch to it using the following command. Let's book read through. Maybe we have to be more specific and send it the full path. Let's try it. All right, so that worked. But we can see a message here. So we're now in a detached head state. You can look around, make experimental changes, and commit them. You can discard any commits you make in this state without impacting any branches by switching back to a branch. If you want to create a new branch to retain commits. So let's ask the AI about this. So we're just gonna say, we're gonna paste this in, and we're gonna say, what happened here?
Your experiencing is common when dealing with Git branches that exist remotely but are not yet recognized locally. This is a good opportunity to deepen your understanding of Git, a tool that's crucial in many tech roles, especially those that are remote. Here's the breakdown of what happened. First attempt. You tried git checkout grams_book_read through, but your local Git didn't recognize that branch because it hadn't fetched or pulled that branch's information yet from the remote repository. Second attempt. You tried to create and check out a new local branch, grams_book_read through, and set it to track the remote branch, origin, grams_book_read through.
Yep.
This command failed because the remote branch's information was not yet available on your local machine. So Git couldn't establish a tracking relationship. Third attempt. You managed to check out the remote branch directly, which landed you in a detached head state. This means you're not on any branch right now, but you can look around and even make commits. However, those commits won't belong to any branch unless you create one. Now, to fix this, return to known branch. If you're in a detached head state, first get back to a known branch. Bash copy code to check out main fetch information. Run a fetch to make sure your local Git knows about all the branches that exist in your remote repository. Bash copy code to fetch origin check again. Use git branch to see if grams_book_read through appears under the list of remote branches. Check out the remote branch. Try taking out the remote branch and setting it to track the remote. Bash copy code to check out grams_book_read through origin, grams_book_read through. This should create a new local branch named grams_book_read through that tracks the remote branch of the same name. You can then proceed to make changes, commit them, and push them to the remote repository. This is an essential skill for remote work in tech, so it aligns well with your career goals in network automation and remote job opportunities.
All right, looks good for me. So we've got the git checkout main. We did that. So now let's do the git fetch origin command. All right. So next command is git git branch A. We're going to see if this appears under the list of remote branches. All right, and it does as it did before. So the next step is to check out the remote branch, and then setting it to track the remote. So this should be it. This will create a new local. So we got to create a local branch that tracks the remote branch at the same time. Then you can proceed to make changes, commit them, and push them to a remote repository. So there's a big difference between remote branches and local branches. If you want to work in one of the remote branches, and the other thing is, like, you know, I think it's not like, you're not meant to work in remote branches. Like, it's not, you know, working in somebody else's branch. I'm not sure if you're meant to do that. I don't know. Let's ask the AI. Is the reason this is so complicated because you're not meant to work in remote branches? You're meant to make your own unique local branch and work in that, and you're never meant to actually pull down someone else's branch? Is that why?
Git system actually offers the flexibility to work in various ways, but you're touching on a principle that is often followed in collaborative coding environments. It's generally good practice to create your own local branches to work on specific features or fixes. These local branches can be pushed to the remote repository as new remote branches, which can then be reviewed and merged into the main codebase. However, that doesn't mean you're not meant to pull down someone else's branch.
Yeah.
There are legitimate reasons to do so.
Okay.
Code reviews. You might want to pull a colleague's branch to review their code locally before it's merged into the main branch. Collaboration. If multiple people are working on the same feature, they might share a feature branch. Resuming work. You might be taking over work from someone else and want to start from where they left off. Hotfixes and debugging. Sometimes it's easier to reproduce and understand an issue by checking out the exact branch where the issue exists. The complications arise because Git is designed to offer maximum flexibility, which inevitably comes with complexity. You can fetch, check out, merge, rebase, and interact with remote branches in a variety of ways depending on your specific needs. And understanding these workflows is pretty valuable, especially if you're aiming for 100% remote work in a niche tech field like network automation where managing different versions of network configurations could be a daily task. Remember, each Git operation has its place, and the best approach often depends on...
Alright, so this looks good to me. We've got now we've got the branch, and we're switched to it. So I'll do a git status. Everything looks good. I'll do an ls. Alright, and now that we're in that branch, we've got the book notes folder, so we can see it right here in the Windows Explorer. So let's open that. And then let's add the network development lifecycle. Okay, so this occurs on page 54. And then we can just copy and paste directly from the book. It says, well, let's just say modern. Yeah, let's just copy this title, paste that in there. All right, and then we'll copy the actual life cycle, which is described here. Oops. There we go. All right, so now we're copying this. Okay, that looks good to me. Paste this in. Okay, so we got some weird formatting there, but it's probably fine. We just got some special characters here, but yeah, it looks good to me. All right, so now that we've got that saved, okay, so we're back to chapter 4. So there may be immediate needs for an automated solution, and while it may be tempting to jump right into making automated changes to the network, it is strongly recommended to begin with information gathering, and I would add to begin with creating that new network development lifecycle, and yeah, so spend time breaking down the network into the building blocks of enterprise design and logical functions. All right, so for example, for the enterprise lab network, we have a core distribution and access layer, and then the production enterprise network will mirror the lab network, so it has the same layers, the core distribution and the access. In addition to that, we also have the enterprise data center, the enterprise WAN, the enterprise demilitarized zone, DMZ, and public access zone, PAZ. Then we have public and private clouds. So I kind of have that set up in my lab. I did that in the last video. To select the required Ansible modules and to identify differences in configuration syntax, further break down the network into hardware platforms and software versions. Code differences exist between platforms for the same commands or configurations. Now that configurations are being automated with a goal of idempotency, coding for the sometimes subtle differences in running configurations across the various platforms and software version in an enterprise is a necessity. The more standardized the platforms across the network, the more uniform the code becomes. Here is an example of a network hardware audit. So so this is like the first thing you can do with automation, and then you can build out your network development lifestyle by building up your source of truth, just by pulling in doing a network hardware audit. And I'm not sure if they'll go into things like this, but there's something called a DFS algorithm. So let's learn about a DFS algorithm from the AI. What is a DFS algorithm?
The term DFS stands for depth first search, which is an algorithm used for traversing or searching tree or graph data structures. One starts at the root, selecting some arbitrary node as the root in the case of a graph, and explores as far as possible along each branch before backtracking. How DFS works. Start from a node, usually the root. Visit. Mark the node as visited. Explore. Move to an adjacent unvisited node and go back to step 2. Backtrack.
Yeah, so see what I mean? Like, even if you don't know what your network looks like, you can use something like the DFS algorithm to discover your network, without knowing what it looks like beforehand. So already right there, just having the ability to apply algorithms to your network, instead of just one person, doing something at the command line based on tricks that they picked up. That's a big advantage right there. So start thinking about various common functions or features enabled on the network. Note any commonalities amongst groups of devices by platform, iOS, or function. This will help identify patterns in the configurations to help in writing templates later. For example, core layer, which would be Catalyst 6500 platforms, virtual switching system, VSS. So these are commonalities amongst groups of devices that you can note. You can note commonalities in the core layer, such as the platforms, whether they're using VSS. You can note unique QoS models. You can note VLANs. You can note VRFs. You can note OSPF, EIGRP, static routing, so routing protocols. You can note port channels. You can note physical interfaces, virtual interfaces, and then the IP addresses on them. In the distribution layer, you could take note of the platforms as well, and notice that they are different. Catalyst 4500 in the distribution layer versus 6500. You can note whether they are using VSS. You can note the standardized QoS model, MQC. You can note ACLs, VLANs, VRFs, OSPF /routing /static EIGRP /static routing. You can note physical interfaces and then virtual interfaces, same as the core with IP addresses, but you'll probably also have some IP helpers for DHCP on the distribution layer. And an IP helper address is for if your server, typically a DHCP server. I'm not sure if you need this for DNS as well. I can't remember, but definitely for DHCP, if your DHCP server doesn't exist on the same local area network, you need to tell the devices where to go to contact that DHCP server. So when the devices send a DORA exchange, they initiate it with a broadcast packet, a broadcast discover packet. That packet can be routed unicast out to the actual server that can process it. So then on the access layer, same thing with the platforms. In this case, it'll be 3850 platforms. You can look at the QoS model, which will be the same as 4500s. MQC might be different though, but you can see that automatically. You can look at the stack-wise topology. You can look at power stacking. You can look at the Catalyst 3750 platforms, the unique QoS model, MLS. the Stackwise technology, power stacking. You can look at the Catalyst 3560 platforms, QoS model, same as 4500 MQC. Catalyst 2960 platforms, unique QoS model MLS. ACLs, VLANs, physical interfaces, various profiles, wireless access points, PoE devices, spanning tree protocol settings, VLAN, voice, QoS security. You can also look at virtual interfaces, default gateways. So then iOS and NXOS global configuration enterprise standards, which would be banners, AAA, Radius, NTP, DNS, SNMP, syslog, archive, boot version, standard global configurations. As expertise improves, verify other candidates for future automation to expand the scope of coverage. Most devices will follow the same methodology used to automate network devices. Other candidates include data center networking, load balancers, firewalls, network appliances / controllers, cloud devices, which I kind of skipped the order. So storage devices, then cloud, as I mentioned, and then Windows servers and Linux servers. A library of supported vendors and available Ansible modules can be found here. All right. Oh, wow. Lots of things. I wonder if they have like a DFS. Something with DFS. Let me use I'm going to search the box. DFS. No, I don't see anything. All right, so next section is network automation readiness evaluation. So before beginning to write playbooks or creating data models, take time to evaluate the network for automation readiness. Automating a poorly designed network is a much more difficult task than automating a well-designed network. In fact, it might not be possible to fully automate a network that lacks basic standards. After all, a big step in network automation is full configuration management that leverages dynamic templates. So I have something to say, but I'll finish reading this. A network without basic standards cannot be templated. The ability to automatically gather information and run one-time tactical playbooks exists. However, full configuration management may be difficult to achieve. Some items to consider when determining network readiness. So I just want to point out that regardless of how much basic standards are lacking in a network, just by nature of those devices being produced and sold by vendors, there's always going to be a standard. So like even in a multi vendor device, once you know what kind of device it is, be it a Juniper, Extreme, Cisco, Telco, Dell, HP, Mellanox, Arista, Aruba, you're going to have some standards there. You're going to know, what things look like to some extent. So even if there's not things that make it really easy, this idea of it not being possible to fully automate a network that lacks basic standards, I think that might be like the line for that is probably pretty far. It's probably always going to be possible. Really all you need is to know what kind of device it is, and then regardless of what's on that device, you can have your automation queue off of things that are coming directly from the vendor. Where it gets tricky, of course, is if it lacks basic standards and you put something on there. You can always at any point be told that what you did was wrong and you made a mistake, or you didn't do something approved, or you are in some way behaving badly on a network. When there's clear standards, you can do things on the network that are clear. When there's not clear standards, you might be in such an environment where anything you do is wrong, no matter what you do, and standards are more just about what's on the device. It's about what people believe are standard to do on the network or not. If that's not clearly defined, then that's where, it's probably not possible to automate the network, because your access to it is going to be restricted in a way that doesn't allow you to do the things that you need to do. So like even like a this sort of thing, like a network analysis, like for example, like TAC x-axis. Let's say they don't even, it's just like they have half the network you can't even access, because like, there's no access standards, and someone's just like, I want these devices for me. I don't want other people messing with them. I'm gonna lock everyone else out except for me. Like, there's not even role-based access standards on the network, and like, that's an example where it's impossible to automate an environment like that, because you don't even have access to all the devices that need to be automated. All right, but some items to consider when determining network readiness are campus design, core distribution access layers. Layer 1, that's a big one too. If you don't have the SSH, in-band management access, you can't do anything. You might be able to automate the out-of-band somehow, but layer 1 consists of physical connectivity, standardized interfaces for uplinks, copper or fiber, and speeds. And then, it can get even more complicated than that. It can be rollover, crossover cables, it can be transceiver, light wave settings for the fiber. It can be, the wrong wavelength. So yeah, it can get this layer 1 really, that's a big part of what networking is about, and really it's hard to take that for granted. Then layer 2 and layer 3, this is the boundary at the distribution layer. It has a standard. So these are the things you need to consider when determining network automation readiness. So you need to consider the boundary at the distribution layer. You need to consider the standard VLANs, and you need to consider the IP address scheme. You also need to consider established patterns for buildings/floors on the campus access, summarized IP address spaces, meaningful IP addresses, some standards for point-to-point links, routes, and routing tables. So aside from that, layer 2 and layer 3, you also need to consider more broadly naming conventions, standardized servers for NTP, DHCP, DNS, syslog, and SNMP. So that's a big thing too. And even on my lab, I just pinned up a DHCP server over here. So like on your production network, people doing that, it's just going to be a nightmare to automate that, because like you have to chase down all these IP addresses, and that can be hard. That can even be sometimes like impossible, because if you can't access the area of the network where this stuff is on to look up where these things are actually going, it could just be too hard to tell the more complicated the network gets, and networks can get really complicated. All right, so the next more broad thing to look at is the iOS versions, the QoS modules, the standard port configurations, so the SVIs, the numbering scheme of those, the physical ports, port channels, access ports, trunk ports, the access port standards, data and voice VLANs, spanning tree toolkit, QoS, 802.1x, port description, power over Ethernet, trunk port standards, native VLAN, VLAN list, port description. So ironically, the first automated task may be using Ansible to perform the network reconnaissance to prepare the network for Ansible. I'm not sure why that's ironic, but I mean that seems totally fair, and that's kind of one of the advantages of network automation. I mean, it's just like you can create this network that it's like it makes sense. And like, you can, it's like having a, you can like write the manual for it. It's like a network without a manual is harder to work on than one that has one. And it's hard to keep and maintain that manually. So that's a great first thing to do with automation. Build that new network development lifestyle, and then after that, write a manual for your network. All right, so at this point, confirm that all the architectural components are in place and are able to communicate with each other. If not, work with the network operations team or server administrators to help finalize the environment. A final checklist, Microsoft TFS, so that could be the Azure DevOps server, it could be GitLab, or it could be GitHub. It could also be Jenkins, but make sure that is configured and licensed. Make sure that role-based access is in place, so not anyone can just go in and blow away your whole source of truth for the network. That the people who you want to work on it have read-write access. The people that you just want to see it but not make any changes have write access. And then the people that you don't want into it at all, like for example the general public, can't see it at all. Then you need a repository created for the environment. You need a link to repository published. You need to be able to communicate with VS Code /Git on developers' workstations. You need to be able to communicate with Git /Linux on the host running Ansible. Yep. And let's look at that. So this automation server, in addition to having to connect up to the network, you also have to connect up to the internet, to wherever your TFS is. So it could be on the server itself. It could be somewhere off, like in the cloud. You need both of those connections. And the good news with that is when you're doing things with TFS, you're not affecting the network at all. So you can do things like set up the network development lifecycle, get that all going without even having access to the network yet. Right, so yep. And then certificates and PKI. So that's like web authentication. You need that public key infrastructure, I think. So then that's on the Microsoft TFS server, which could be on the same Linux host. It could be somewhere else. But on the Linux host that you're using to connect to the TFS server and connect to the network, so in my case it would be this one right here, you need to make sure that host can reach network devices through SSH, that it can reach TFS through whichever port you want for it. You need to make sure that Ansible is installed. You need to make sure that the repository is cloned locally from TFS. So let's go through each of those steps in my lab. So the first thing we need to do is make sure that the devices can be reached through SSH. So that is definitely not the case right now. So I kind of want to work on it a little bit. So here we go. Here's Visual Studio Code. Here's the book. So let's do ARP. Okay, so we've got some of these. Let's try pinging 172.16.1. Oh, and I don't have my. Oh, I can't use my numpad. Okay, so we'll ping 172.16.0.1. That's myself. We'll ping out to the network. .3 looks like we got. .2 we got. What about .4? Don't got .4. What about .5? Don't got .5. All right, .6 maybe. And .7. Maybe .8. I don't think there is a .8, but anyways, unfortunately we can't get to all those. I'll have to actually say, and this is what I mean, is like as much as people want to accomplish with automation, like, the non-automated way is never going to go away. It's always going to be necessary to manually do things. So this is the Viptela device. So yeah, we don't have SSH access to the Viptela device yet. And you can see, we're logging in with this. We don't even have that username set up on it. I don't have this set up yet. I don't even have the TFS set up yet. I do have Ansible installed. I thought I did. Yeah, I do have Ansible installed. And then I do have the repository cloned locally from the TFS. I'm using GitHub for my TFS. I might have to change that at some point, but this here is a repository, a TFS style repository that the book is describing. I'm using GitHub for that, but I might need to very quickly switch to either Azure DevOps Server, Jenkins, or GitLab. All right, so VS Code, you want that installed on either Windows or Linux Developer Workstation. I have it installed on my Linux Developer Workstation in my lab. You want extensions for Python, YAML, Jinja 2, Git, Ansible, and other file formats. I've got that. You want the repository cloned locally from TFS. Yep, and we already did that up here. And then for the network, you want a service account created for Ansible playbooks to authenticate. That's a good point. You really want to see what's happening through automation and what's not. So you really do need to get a separate TACX, Radius, even like a local box account. You have to separate that out because you want to see what's being done by the automation and what's being done people. That's really important. So you don't want just everything to look like you don't want to not be able to distinguish what type of activity is happening on your network. So you do need that service account for your automation. And then you need Ansible playbooks, have the method of authenticating. You've got to give them the password to your network or get the keys set up. All right, I feel like I might be at that 1 hour mark. Let's check the clock. Oh, I'm only at the 48-minute mark. Okay, so I think I can probably do some more. I'm going to pause it and I'll be right back. All right, I'm ready to keep going. I'd like to get to the... Mic check, 1 2 1 2. Okay, I'm ready to keep going. I like to get to the 1 hour mark, so that's about 12 more minutes. So let's keep reading in the book. So the next part is processes and the network development lifecycle. New organizational processes need to be adopted and formalized before beginning, even if only in the information gathering phase. This ensures new processes have time to take hold and the team is ready to follow the new oh my god, this book is so naive. The new network development lifecycle. This new network development lifecycle includes creation of a centralized TFS repository, creation, which is going to cost you money. I guess you could use Jenkins or GitLab and do it for free, but the Azure TFS will probably at some point cost money, and then same thing with GitLab. And then the other thing with GitLab is like everything's public and you have to pay to like make it private, and you're going to need a private. So like, for GitHub, GitLab is probably the good one to use because that's open source. And then Jenkins if you need more robust CI/CD. So that's what you need is the creation of a centralized TFS repository with your role-based access set up. You need the creation of a master branch. You need to use working branches such as feature requests or bug fixes for all changes. You need to commit code often using Git. You need to use pull requests to merge tested code into the master branch. And you need to establish the associated approval workflow in TFS. So iron out the details of this process before starting to build the solution to make the change gradual and the transition smooth. Have new automation meetings and discuss possible quick wins or any immediate needs that can be met using the newly available capabilities. Focus on how information gathering and network reconnaissance playbooks will be of immediate value to network operations. Get the operations team excited and involved in running and requesting playbooks. Build a library of reconnaissance tools, gradually moving towards automated changes. All right, so the next section is training and transition. The transitionatory phase is likely one of the most painful parts of adopting any new technology. There is natural resistance to change. Several new tools are being introduced all at once, stressing the importance oh my god. Stressing the importance of following the new processes for network management is the most important component of a I don't know if this guy's ever read the Lorax, but I think this person needs to go and read the Lorax. That's very relevant to this. So stressing the importance of following the new processes for network management is the most important component of a successful transition to network automation. The philosophy of automate everything must be adopted by everyone for this to work. Manual out-of-band changes cannot be tolerated by the Lorax once full automated network configuration management has been put into effect. Conflicts between the manual changes and the source of truth will exist. Most likely, these manual changes will be overwritten and lost the next time an automated change is made. This occurs because the changes were never added to the code repository, which leaves the network potentially impacted with no way to track what happened. I don't know about that. This hazard exists and therefore should be avoided at all costs. Staff need to be educated on the serious and negative consequences of making manual changes. I mean, you can write code into this because it's like, you can just do network scans a lot. And then if you see a new change on there that doesn't match the TFS, you can flag it and report it and be like, what the hell is this? I just feel like this idea of becoming the Lorax and speaking for the trees and having nobody listen to you ever is it's just I need more than this. It's I just feel like, this presupposes a level of influence that is hard to get. All right, so network engineers need to be a substantial lead ahead of network operations, as they will likely be the ones writing the initial playbooks and converting the network to code. Network operations can then be trained on how to execute the playbooks. Over time, more NetDevOps can be adopted, and network operations can start updating the data models and potentially write their own information gathering playbooks, while the network engineers continue to write logical templates and potentially more complex or new data models. All right, next section, build repository folder structure. The first step in building the automation ecosystem is setting up the first TFS repository for the selected environment the organization has decided to automate. The repository is the foundation for the NDLC and the source of truth, so it is very important to create a structure that scales and imposes rigid standards. Role-based access control, RBAC, should be configured, limiting access to the code base as appropriate. Distribute the link to the network developers once the security and workflows are in place. Create the first branch, the master branch, which includes the base folder structure and inventory hosts.ini file. A recommended folder structure is covered in Chapter 5. Lock the master branch once populated. Lock the master branch? I'm not sure how to do that. Oh, well, you know what? This is still the early part. They're going to talk about all of this in more detail. We're at Chapter 4, so Chapter 6, they said, was like the big one where they really go over everything. And it looks like Chapter 5 is going to have details in it as well. This is just trying to, like prime us for like understanding what's going to happen later. All right, so the next thing is to create Ansible inventory file, hosts.ini. So once ready to start populating the repository, begin with the foundational hosts.ini file. A considerable amount of time should be spent creating a hierarchical model for the hosts.ini file, building natural logical groups of devices where applicable. These groups are more than just a list of hosts. The group name itself becomes a key accessible to create a group vars YAML file as a data model for all the hosts listed under a group. Organize the hosts.ini file to reflect the logical network topology. Ansible can execute playbooks against different technologies at the same time. For example, against different technologies at the same time. Yeah, so like, we've got different kinds of routers. Sorry. We've got ISR access WAN routers. We've got data center. So like these are different technologies, and you don't have to separate it out by device type. You just need to specify the host name, and then it will run it against, it'll detect the device type and run the appropriate scripts. You don't need to tell it what technology it's working with. It can detect it automatically. So for more information about working with inventory files in Ansible, visit this. So let's visit that. This might be a good one to save because I guarantee you this can get pretty tricky as your network is big. I've worked on, there's networks out there with millions, if not like billions. There's big networks out there in the world. Let me tell you that. So like, I'm just wondering how something like this would be used for, networks so big that the text file would like be like gigabytes of information. It's like, I feel like the better way to handle that than to have a file like that would be to just every time have some kind of like DFS algorithm or like something, some kind of algorithmic access of your devices instead of some kind of static pre-populated list to reference. All right, so the Linux hosts need to be able to resolve these host names. Ideally, populate the DNS server records so Ansible can dynamically resolve host names. And then otherwise, update the local /etc/hosts file and create static records. Oh, interesting. Oh, okay, I see. No. So this is talking about accessing devices. You can access them through an IP. You can access them through host names, but you can only access them through host names if you have DNS. If you don't have DNS, then just update your local etc hosts file, and then you can still access them through host names. So building the host.ini file might be trivial provided an accurate inventory system, an up-to-date IP workbook, network topology diagrams, or NMS inventory system exists. And otherwise, that's a key word here, it may take a bit of manual discovery to ensure complete coverage of the network. At this point, the network is operating in manual mode and will be unable to use Ansible to help build its own inventory file. I don't agree with that either. Like, this is where I feel like sometimes Ansible is limiting, and like teaching people to use Ansible is like, you should be teaching people to code. Like, forget about Ansible. Like, learn to code. Don't learn to use Ansible. So, like, we could use a DFS algorithm and we could map out the whole network if we're working in code. If we're working in Ansible, then we can just use whatever features Ansible has available. So, like, that's what I would say. Like, learn code. Like, don't learn Ansible. Learn to code, because then you can put these really powerful algorithms to use and do things like populate your own inventory file. So use Ansible to run the show iOS, the Cisco iOS show CDP neighbors command, which you will not see any non-Cisco gear. You have to use show LLDP neighbors, and you have to have that enabled. So, I would say a better thing to do, and I've done this before, do a broadcast ARP, or like if you find a like do a ping of a subnet, like maybe even using like Nmap or something like that. Get all the ARPs, so like you can see what's resolving, and then use your DFS algorithm based on that. So every segment of the network, you do a broadcast ping, or like you look at the ARP table, you look at like the routing table, the MAC address table. I mean, the ARPs are gonna be the best way to see what's on your LAN. So do a broadcast ping and look at your ARP table, and then for each of the IP addresses you get back, try to connect to those, and then algorithmically use a DFS algorithm to go through your whole network and build out a file, map out your whole network that way. Basically, just learn to code, please. All right, so use Ansible to run the Cisco iOS show CDP neighbors command, and use the output to map the network if necessary. Ideally, export a list of devices from your NMS or offline documentation. However, do not underestimate the effort involved in building and maintaining this INI file. Exactly. Please, yeah. I say learn to code, use the DFS algorithm, but that's hard. You could do it with all coding is hard. Coding is basically just thinking as hard as you can for as long as you can, and that's hard. All right, so gather information. Network reconnaissance is a massive challenge to tackle on an enterprise network, even with powerful network management systems in place. Many commands must be executed at the CLI to capture the information required to troubleshoot a problem or to design a new solution. It can be tedious and cumbersome having to hop from device to device and collect information that could very well be stale or obsolete by the time the change is drafted. It especially does not scale well for larger changes. Now that the inventory file host.ini is ready, Ansible can execute playbooks against the devices. Some advantages to this approach include excellent starting point to network automation, non-disruptive, non-intrusive, no chance of anything going wrong, simple and easy to get going, basically converting the commands normally to run on a device to a simple script, dry run process, start building a centralized library of customized network utilities available for engineers or operators to run on demand or scheduled for execution daily/weekly, start building dynamic network documentation, So understand the network, layer 1 topology, layer 2 topology, layer 3 topology, Cisco Discovery Protocol neighbors. If it's multi-vendor, you have to use LLDP. Open shortest path first, OSPF, enhanced interior gateway routing protocol, EIGRP, border gateway protocol, BGP neighbors. Then routing tables, VLANs, interface availability / usage, and then the other advantage of this approach, and the approach is using network reconnaissance. Is you can improve your software development skills. As I said, you can learn to use that DFS algorithm. So you're coding. That's the advantage. Like the more you code, the better you are at coding. So get coding, stay coding. It's important to code in order to be good at coding. All right, so using Ansible offers many ways to gather information from the network. This book focuses on the Cisco iOS_facts and iOS_command modules that are natively included with Ansible installation. So now this is iOS, so I'm not sure if Ansible will even work with complicated multi-vendor environments like I have in my lab. But you know what I can do? I'm willing to do. I'm willing to ditch Ansible, just like I'm willing to ditch Azure DevOps server and use something else. So I'm going to be perhaps not following exactly along with the book, which might mean it takes me longer to get through this. But I'll try as best as I can to just follow along. All right, so the next part is Ansible module / iOS facts. So I'll center it there, and I'll hit Control S, and then I will take a look at the clock. All right, so we're well past the hour mark, so that's going to be it. Stay tuned for the next video where we go over the iOS facts Ansible module.